All right, topic of our video today. What is a series circuit? A series circuit is going to be any circuit that has more than one electrical load, but only has one path for current to flow. So we're going to take a look at some series circuits today, and we're going to learn some of the characteristics of series circuits. We're also going to learn about the laws for series circuits from Ohm's Law. All right, so a circuit is a complete path that electrons have to flow from the power source into the load, and then from the load back to the power source. We have a complete circuit. A series circuit is going to be a circuit that has more than one load, but only has one path for current to flow. So a series circuit is going to look like this. We're going to have power wire with our circuit protection going into our first load. The wire coming out of that load, instead of going right back to the power source, is going to feed into the next load. After that, we have our ground return path that's going to go from that second load back into the power supply. And the first thing you'll notice with these two bulbs in series is that they're a lot dimmer than when I just had one individual bulb, okay? Because the bulbs now, because we have two loads in the circuit, these loads now are having to share the available voltage, okay? So I've got my multimeter here set to read DC voltage, okay? And if we measure voltage from one side of the load to the other, it'll tell me the difference in potential of how much voltage is there, okay? So if we go back to a circuit that only had one load, we hook this back up, what we will see is that the load difference in potential is going to be on this one about 13.3 volts, because my 12 volt power supply is actually a little bit higher than 12 volts. So it's about 13 volts, okay? So we see that the difference in potential, so that tells me that voltage going into this load is about 13, and voltage coming out of that load should be close to 0 because my load used up all the voltage. This is what we call a voltage drop test, okay? Voltage drop is a measurement of how much voltage is used, okay? So the multimeter, whenever we're reading voltage, always reads the difference in potential from the red lead to the black lead. So there's 13.3 volts difference in potential between here and here. So across that load, it's using 13 volts, okay? Let's go back to our series circuit and see what that looks like. So we have our power wire going into our first load. We got a wire coming from that load into the second load, and then our ground return path plugs into that second load. Now we see that these bulbs are much dimmer, and they're going to be sharing the voltage. So let's check that voltage drop across that first bulb again. And what do we see now? About 7 volts. Let's see what we've got for the second bulb. About 6 volts, and 7 plus 6 is 13. So we have all of our voltage accounted for, okay? We're going to learn about several laws as we're learning about electricity, okay? One of the laws that we're going to learn about is Kirchhoff's law. Kirchhoff's voltage law tells us that all voltage must be used before returning to the power source. So if I have 13 volts available in this power source, all 13 volts must be used before it becomes back to the ground side of this power supply, okay? So here we can see the voltage drop in bulb 1 versus the voltage drop in bulb 2. They're similar, but they're not quite exactly the same. If we do find two bulbs that are exactly the same, they'll be a lot closer. Let's try with these other two bulbs that I have on my board here. So we'll just move these down and see what these look like. Those look like to be a little bit closer in brightness. So let's see what those look like now. We got about 6 volts there. Notice it does say negative. Now that negative voltage really doesn't mean anything to me. The only thing that negative voltage is telling me is that I've got the polarity of my leads backwards. So if I take these and I flip them, I'm still reading 6 volts, but now I'm reading positive, okay? So I got about 6.7 volts there. Let's see what I got in this one over here. We got about 6.5 volts there. So those two bulbs are much closer, okay? In a series circuit, whichever load has more resistance will use more voltage. So these are very close, very similar in their resistance. The first two were a little bit different because this one was reading about 7 volts and then this one was reading about 6 volts. Still accounted for our 13 volts, but we could tell that this load had a little bit more resistance than the other one. Therefore, it was using a little bit more voltage than the second bulb. These two bulbs, very similar, pretty close to 6 volts apiece. Okay, so our series circuit has several laws. Okay, first law of a series circuit is that the total resistance of a series circuit is equal to the total of all the resistances in that circuit. So if we take the resistance of bulb 1, the resistance of bulb 2, we add those together, we would get total circuit resistance. So let's say each one of these bulbs has 2 ohms of resistance. Total resistance for this circuit would be 4 ohms, okay? The second law about series circuits is gonna have to do with amperage. And I'll try to keep that so that it's not glaring, but let's flip this over and let's measure current flow. So I've got my multimeter now set to read DC current, okay? I can measure the current going into this circuit. And I see that I've got about 1.4 amps there. Well, if I measure the current flow in between these two, I should see that my current flow is about the same, about 1.4 amps. And then if I measure current flow coming out of that circuit, going back on my ground wire over here, it should again be the same at about 1.4 amps. Amperage in a series circuit is going to be the same no matter where you measure it because there's only one path for current to flow. All of the current coming from the battery must go through each of these loads and return back to the source. Remember, current flow is the movement of electrons, how many electrons are moving. So as those electrons are moving down the line, each electron takes the place of the next one in the next atom. So the amount of electrons that are moving here in the power wire going in are going to be the same as the amount of electrons that are flowing here in the ground wire going back to the load, going back to the power source. So current flow is going to remain constant no matter where we are in the circuit, okay? And the last one is going to be voltage in a series circuit. Voltage in a series circuit is going to be used in proportion to the resistance value of the load compared to the rest of the circuit. So with these two loads, they are roughly the same amount of resistance, and therefore they roughly use the same amount of voltage. But I've got another little bulb down here. Now this little bulb has quite a bit more resistance than either one of these, okay? So as I build a series circuit using this small bulb down here, if I just take these two wires and move them down here, oh, we see we only got one bulb glowing now. Do I still have a series circuit? Let's see. I got a power wire coming into this bulb. Coming out of that bulb, I have a wire going into my small bulb down here. And then coming out of that bulb, I have the wire going back to the ground. If I break this circuit, it stops working, okay? Create an open in the circuit, there's no more current flow, okay? It is still a series circuit, but because this one has so much resistance, it's not able to share voltage very well. He's hungry, he's eating up all of the voltage. not leaving much left over for this guy over here. But it is still a series circuit, because one of the things about series circuits is if one of the bulbs goes out, all the rest of the bulbs will go out too. So if I remove this bulb goes out because I broke the path. There is no longer continuity in this circuit. When I plug this back in, this bulb will light back up, okay? And if I switch these over here, go back to my other bulb, we'll see that they will act the same way. They're in series, they're sharing voltage. Current flow goes through both of these bulbs. If I remove one of those bulbs, both of the bulbs go out. So it is a series circuit, but only this bulb is glowing because it has so much resistance. There's not enough voltage for this guy over here. Let's see how much voltage this little guy down here uses. I say little guy because he's smaller than the rest of them. Oh, that was the wrong setting for the multimeter. Let's put this back over to voltage. We'll plug this back in here. We see that this bulb is using 13.2 volts. This bulb over here, it is using a little bit. It's using about 0.2 volts. So it is getting a little bit of the voltage, but not enough for it to glow. This is the only one that's going to be able to glow because it has so much more resistance than the other. So it's eating up the majority of the voltage that's available. All right, so let's go through those laws one more time. In a series circuit, total circuit resistance will be all of the resistance values added together. Current flow will be constant no matter where we are in the circuit. And voltage will be used in accordance to the total resistance of the circuit versus the resistance of the load. But an easier way to think about that is whichever load has the most amount of resistance is going to use the most voltage. The big dog will eat more food. All right, so that's our series circuits for today. So we learned our series circuit, we learned what a series circuit is, and we learned about the 3 laws for series circuits. Thanks for watching. I'll see you in the next one.